Right, ladies and gentlemen, I think we'll get going. So thank you for joining this afternoon. We're recording and we are projecting to the world via GoToMeeting. So this afternoon's session is a continuation, actually a continued workshop series, I suppose, on geoscience, community ontology engineering, and we've been kind of trying to hone how these have been working. I think this is going to mark the fourth that we've done so far, and we're learning as we go along. They're not working so well when we start writing code and start getting there, I don't think, but I think this is an excellent opportunity for us to debate and hash out a lot of the issues which we encounter when we try to do ontology engineering for the geosciences in particular. So that's really where this is geared. Hosts are actually myself. Pierre was not able to make it. His flight or his travel plans were butchered. However, we're going to hear from Ruth Duer, Gary Berg-Cross, and Chuck Vardaman, as well as myself today. So that's who we will be hearing from. Remote participation links are there for anyone that, or I should say for others that's also on the shed. The goals, okay, so these goals again have kind of been changing as the workshop series has been, I suppose, evolving and maturing a bit. They've been changing, and I think in line with who we expect to be at the workshops and really what we expect people to, or what the expectations are of attendees, let me put it that way. But the first one is essentially just to bring together technologists, in particular semantic technologists, together that have an interest in the knowledge representation or knowledge space for use in informatics. Really what we're trying to do is we're getting bigger on harmonizing a lot of different knowledge resources, and this is an excellent forum to bring together people who may be developing knowledge resources or consuming knowledge resources and have found limitations in the way in which they can do so. Second goal here is that we'll provide you with an opportunity to hopefully work on a variety of tasks. So when we're talking about ontology engineering, there's a couple of facets there really. We've got what's now referred to quite widely as semantic harmonization as one piece of it. As I'd said, if you're maybe an author of knowledge resources, then we also cover parts here of maybe how you would contribute to or consume parts of existing vocabularies and ontologies, particularly Suite and Envo. But the point is here that it's an open forum for us to try and cover some of that spectrum. 3, we should hopefully leave with an understanding of current semantic harmonization initiatives. So if that's something which you're interested in, I think there's a growing number of us that are interested in that field, then hopefully you'll leave today with an understanding of where that's at and how you would maybe get involved in it if you want to. To identify and drive future semantic harmonization initiatives. So if there's something which is not covered from what you see today, then this is also the forum to try and voice that and for us to make some progress there. And then 5, to notionalize a new concept which we're referring to here, which is the Earth and Space Systems Ontology Foundry. This is hopefully for open discussion, and we think that we'll be moving in the direction of creating a foundry for Earth and space systems, the same as something similar to which has been done over at the OBO Foundry for that particular community. And the reason for this is that semantic harmonization is a non-trivial process. Right now, there are ad hoc means by which we achieve semantic harmonization or try to work in semantic harmonization. And we think that some larger organized activity, and the concept of a foundry comes to mind, would potentially assist with that in particular. So the agenda is going to be, Pierre had provided us with a video, a 15-minute video, because he's not going to be here. We'll have a look at that. We'll recap what happened at the AGU workshop, and I see a few faces of folks that were at that workshop as well. Actually, I would say there was about the same number of people at that workshop. It's excellent to see we're getting some interest at the beginning of these sessions. Interest kind of falters towards the end. There's no doubt about it, but it's nice to see similar numbers. Bulk of today will be spent between semantic harmonization. We'll hear from both, Ruth, Gary, and Chuck in that area. Then we'll go into the open discussion, and then the very end. This is 5 minutes on how you would get involved if it sounds appealing. So really, what you need, I think, if you intend to participate now or later, is a GitHub account and an ORCID. And the reason for the latter is that we've been working on nano accreditations for contributors. We've got a process for acknowledging incoming contributions, and the way in which we do that now is through ORCIDs and some other metadata. But these are the only two things you need. It's very low barrier to kind of getting involved here. Okay, and I think before we get on to that agenda, I did want to ask the audience just now what we had coming to a session like this. What really are you hoping to get out of it? When we talk about activities such as semantic harmonization, and when we're thinking about tasks such as ontology engineering or disciplines such as ontology engineering, you're here for particular reasons, maybe different reasons. Bearing in mind that this has been I suppose a series of workshops. This I believe is the fourth one of them. There are some new faces here, and I did want to maybe just open it up initially before we get on with the agenda to ask what it is from today, or what it is that you're interested in working on over the next while that pertains to ontology engineering within the geosciences. Does anybody want to give their input on that one before we get started? Maybe something, and feel free to add whatever you want just now, but maybe something which lies outside of that agenda. It's something you maybe want to cover or what would like to have considered at least.
Yeah, this is kind of a general comment. I just want to be part of the solution and not part of the problem.
Yeah.
And so just getting some guidance on better ontology practices.
Okay. Sky?
So yeah, I have kind of a practical use case. I mean, I sort of understand how this is all working in theory, but I really want to understand more of the practice of it. Right now, in particular, we've been collecting observation data for as part of the Ocean Biogeographic Information System of environmental measurements taken in concert with biological observations. We have, I don't know, 460 million observations or something in the data set. They've mostly been tied to terms in the NERC vocabularies. And we have 265 terms or so altogether there. And we need to do harmonization across all of those because we now need to calculate essential ocean variables and various pieces out of all of that. So we really need to have a tool that as that community comes together, and we have all these groups in different subject areas coming together around the world. Pierre Luigi's involved in some of that. And we really need to be able to say, okay, as part of this work in a given workshop focusing on this topical area, this is the way that we capture that knowledge together in terms of what terms we're using where and what they actually mean.
Yeah, okay, Sky. Hopefully, I think we're going to cover quite a bit of that today. I mean, honestly, this semantic harmonization topic has emerged. The downside to that actually is that very few people are funding that work, right? Almost nobody's funding that work. We've seen almost zero investment in that work for up until now. And it's been an issue for a long time. There's a few individuals which are working on it, and honestly, I think the group that's here today, that might be Pierre. Yeah.
Sorry. Go ahead and mute them.
Right. Sorry, Pierre. Okay, so yeah, getting back to where we're at there, you know, harmonization is where it's at. And the ironic thing about this is that ideally, with enough foresight, we shouldn't have to do harmonization, right? But we do have to do harmonization, and we're stuck. That's where we're at just now. Really, the concept of, I think, of a foundry is that there's enough of us looking at this area, having been in the trenches of doing harmonization, that we shouldn't have to do harmonization in the future for as we create more of a fabric covering Earth and space systems. But that's quite some distance off. Okay, so we've got, yes, yeah, thank you.
I'm especially interested in this foundry idea and how the ESIP, the community ontology registry, might be evolved into the foundry, whether that's the plan, just the mechanics of that, because in order to do this harmonization, we need to have sort of reliable, permanent access to dereference the URIs for things we're trying to dereference. We're trying to harmonize. Yeah, so that's critical.
I agree with that. I agree with that very much. You know, Pierre and I had talked before the meeting before this week, and we're going to have a session on what the architecture, I think, would be for a foundry. The logistics, what it would try to achieve, what problems it would solve, but really more the technical components of it as well. Where would it live and how would people access it and these types of things? It's not just another closed repository, but really it facilitates a large part of that fabric that I think has been long desired by community, you know, the larger community. So point very well taken, and tooling as well along those lines as well. By the way, for any of us that were at the NSF workshop yesterday, this is bang on where that sentiment is going as well. I mean, we're dealing with the same issues, and I believe that there's opportunity for NSF to produce a really purposeful and meaningful call for the Convergence Accelerator that I hope can be utilised as a driver to address some of these issues. But we'll see. Anybody else would like to contribute thoughts before we kind of get moving? Anybody at all? Going. Okay. Thank you very much for that. I think Sky and I think that we've got opportunities to address both of those. I think just in general as well, what we can do is make available slides and some of the previous resources for how we've been doing things to address your, like, coming to this maybe new, not to the field, but certainly to where we're currently at. Yeah. Okay, so let's see. There we go. Okay, where we're positioned here is we're currently working on harmonizing Suite in its reinvigorated state with, in particular, Envo. And there's been quite a bit of activity along those lines, many releases and changes, many workshops to facilitate that work. Really where we're at just now is the second from last bullet point. So there's been quite a lot of work since 2017 to really drive things forward. And to be honest with you, this is really in a response. Where we're at just now was envisaged over 10 years ago by certainly my predecessors at ESIP, where with the hype curve for semantic technologies, you know, 15 or more years ago, and then the trough of desperation and the long climb out of that trough. And really where we're at now, I think, is a much better place, that we've acknowledged harmonization needs to be done on a much larger, wider, consensual basis. I think that, as I'd mentioned, this NSF call or workshop yesterday was very encouraging that finally they maybe start, well, I think there's an opportunity for EarthCube in particular to draw a lot of attention to harmonization as a primary field that needs investment. But certainly resources such as Envo and Sweden are in a much better state than they were some time ago. We have had a session accepted for the United States Semantic Technology Symposium, which is taking place in March. So we'll have we've been asked to merge sessions, but the point is that this, for what we do today, will continue, and there'll be more on this in March. Just a kind of shout out here for the Semantic Technologies Committee. We meet once a month. The details for which can be found through this hyperlink. And we try to have these workshops at each meeting. We did try at AGU, which I think went reasonably well. So moving on, we've got a video here from Pierre, which, as it says, about 15 minutes long, and then we can progress on to some of the other topics. So over to you, Pierre. Hopefully.
Hi, everybody. Sorry I couldn't be there remotely or in person. I'm currently stuck on the way to Halifax for the UN Ocean Decade meeting. Hopefully I should be on a plane right now. But for this meeting, I'd like to show you what we do with some of your input that we have gotten over the years, more since our last workshop of this kind, where any issue that you post on the Suite Tracker gives us an insight into the kinds of vocabularies and definitions that you in your field take seriously, that you use, that are good sources for us to work on to translate your knowledge to the machine layer. So that's a really key part of making things more interoperable, one of the ingredients in the FAIR data specification. And if we look, the data principles rather, if we look a little bit into that, it talks about using a formal language for knowledge representation. And that's really what semantics and ontologies are. To use vocabularies, ontologies, the SOI, that are machine accessible and web accessible, so that machines around the world can point at the same thing and say, oh, look, that's what we mean when we are looking at a certain information artifact or data artifact. Of course, that's the technical side of it. We can build that, but what we need from the community is that kind of insight into, hey, look, this is our key vocabulary. This is where people have worked and gotten the definitions right. And also like putting some flags up to say, this is where there's debate. This is where we're not sure, or different sub-communities understand things a little bit differently. So that's really important for us. You'll have to excuse this. I'm recording on the move, so there won't be time for editing. So please ignore any like random pop-ups that might happen. Anyway, where were we? Okay, so that's a key ingredient. We need your sort of instinct to help us shape the semantic layer for Earth science and planetary science, space science too. You know, we're very open to that. And just let us know where you have those definitions, or where those communities have those definitions, or which ones your institutes, your organizations use with high confidence. Then we can start translating it into a way that machine. Right. So that knowledge representation idea. It's part of artificial intelligence. So we've all heard of machine learning. You know, when you have a lot of data that's roughly about the same sort of thing that people talk about in roughly the same sort of way. That's a great scenario for machine learning. Knowledge representation is more like when you have expert knowledge that not too many people know about. So machine learning is like photos of cats or cars or license plates, or things that are fairly standardized. But often we're working in fields where the knowledge is new, or there's disagreement, or sometimes it's just really hard to express. So that's when you use the other branch of AI, knowledge representation, to try to extract that knowledge and put it into machine form. And then you have a whole gamut of technologies you can use to express that those semantics in machine-readable ways. It's called the semantic gradient. And all of these things have their place. You know, it's not really fair to say that, you know, taxonomies are better than glossaries. They're better at some things, but they're perhaps not as good at others. The main thing is that as you move up the semantic gradient towards ontologies, it takes a lot more work to translate that knowledge, because you're making things a little bit more involved and more expressive. It's much easier to put together a controlled vocabulary, and for many purposes that may be sufficient. But sometimes you need a little bit more of heavy-hitting technologies, such as ontologies. when you really need to express subtlety or disagreements. So this is where we're operating. So on my side, I primarily work in the ontology space, so high expressivity, but takes longer to do. That's the downside. So we need people working across this gradient to expose knowledge, to expose definitions in a machine-readable form on the web. And then we can start doing some pretty interesting stuff in terms of at least in making our data more interoperable semantically. So that's what ontology is. I'm sure you've probably seen this definition around. It's just a way of being very consistent and coherent about expressing what things are in relation to other things. So when we see something like that, a volcanic eruption, a machine will just, if you just give it that term in a field, the machine will understand it as just a string. But if you give it an IRI or a URI, which points to a web like an ontology, it will take the machine to what basically looks like a structured graph, which connects that idea, that thing, to other defined entities with coherent links. So it knows what the inputs are, what the outputs are, what the participants are, and each one of those gets linked on. And as you'll see here, there are multiple ontologies that are used to express this, and these are interoperating ontologies. We're bringing that same sort of level of interoption towards Suite, bridging over this family and federation of ontologies that Envo lives inside to the Suite world, so that the expressivity meets Suite's coverage, and then we are all developing the same thing ultimately, so that we can bring together different communities. But we have a cryosemantics hackathon, which we've been working away at with Dur. Notably has gone through hundreds and hundreds of definitions to figure out areas of consistency and disagreement that we're now translating using Envo's expressivity and mapping back to Suite, so that the Suite cryo realm side is in shape, and Envo will provide a little bit more clarity in terms of relationships to other phenomena that are not yet in Suite. But again, as I said, eventually they converge. So ultimately, it's just going to add up to one large semantic layer that's going to be bridging a whole bunch of people that are trying to converge in this field. So coming from the OBO side for biomedicine and biological processes, biodiversity, agriculture, and food. A lot of stuff with the SDGs. We're working with a number of UN agencies who are trying to get out some more data standards for sustainable development, which of course has a very large earth science component to it. The activities within ESIP, and many others. And ultimately, it just wants to be the same sort of knowledge layer at the top. So, okay, that's a brief introduction. And what I'll show you now is essentially what happened on some of the input last year. So last year, Jim was a bit of pioneer in this, and he put in an issue on the tracker, which we encourage everyone to try to do, and said, hey, I really want this quasi-stationary front to be represented somewhere in the ontology space, and I'm not really satisfied with what I see out there. And when we pointed over to Envo, we had some stuff for fronts expressed as layers, but our layers at the time were very sort of horizontally biased, like vertical layers inside the atmosphere, and things were not very well represented. We had some stuff inside a Klein, where we kept oceanic fronts, and again, it's very marine focused. A lot of the input into Envo at that stage had been very marine biased. So basically, it just didn't do the job. So on Jim's request, we're like, okay, we better take a closer look at that. And he was so kind as to connect us with a glossary that he said, okay, this is pretty good. I like the way they define things in there. And there is a Suite anchor. This is on the Suite issue tracker. There's a Suite anchor where I think that this should be developed. He gave us his ORCID so that we can microcredit him as we add the content. Great. So I said, this sounds good. Let me pick it up. And I created an issue on atmospheric fronts over in Envo. So there's the issue over in Envo. Let's just take a look at it. I just described it very briefly. I said what we're going to do. Noting that we do have some semantics for marine fronts, but there's no sort of consistent hierarchy for frontal systems in general. So there was some work done. It was linked to a few other issues that are relevant. For example, back to the Suite issue, and also later on to things like windstorms, which will require the understanding of the atmospheric front systems to really be expressed well. Simon Cox chimed in and said, hey, look, that sounds pretty interesting. We can use that as a basis to add other phenomena with a little bit more, let's say, coherent logic inside the machine systems. So, happy days in general. From that, some work was done. We edited the ontology, and we sent in a pull request to say, okay, here's a pull request working on layers, interfaces, fronts, and clients in aid of, and of course, the Envoy issue and the Suite issue. So we didn't just add one term, because often we don't add one phenomena into an ontology. We have to add a small network of related phenomena so that the machine has a sort of context to essentially reason over, to say, yep, this is possible, and it's linked to the following phenomena. This is a kind of front which relates to other fronts in the following way. And since we're doing fronts, this was a great resource, this AMS glossary. We started just basically going crazy a little bit. That's again why it takes a little bit longer, because we do like to try to flesh it out such that it really improves a machine's perspective on what all of these things are, what processes they're involved in. So we added a whole family of things. Some are still in progress. There's some linguistic issues in terms of understanding what exactly the phenomena is, but we're working on it. Envoy has a multi-planet flexibility in the sense that it's not just about Earth. So sometimes when we say something like, let's say, katabatic wind, we're careful not to bind that just to one planet's atmosphere, for example. But this is a subtlety that often won't really affect the usage too much. So work was done, things were sent in. It's linked out, so the difficult ones we created new issues about, and we'll be working on those, trying to figure that out. And the ontology itself got changed. So now we have fluid layers and different kinds of interface layers. These seem split, but this one is automatically populated with any layer that's made up of a fluid. So it looks split, but the machine understands that they're equivalent classes because we encode the logic over here into the ontology. So we've improved that hierarchy from its previous state. We now have interface layers. This is where we put in fluid fronts, boundary layers, that sort of thing. And weather fronts are in there. And this is where stuff has been added. There's quasi-stationary front, the thing that started this whole process off. A front which shows very little mobility. It didn't really, the definition is not so deep, but actually that's what we extracted from the text and the description. That's more or less it. It doesn't move terribly much. And the definition of front is done up here in terms of weather fronts. That's when we actually define out what we're talking about. So there it is. We quote some material from the glossary. Of course, we always link back to the source we got it from. That's my ORCID as the creator of the term, and that's Jim's ORCID as the contributor who contributed the knowledge to the ontology. And then we created this little network around it. And it's really great because, again, Envoy's atmospheric expressivity was relatively low until we started this, and now we have a horizontal interface layer, a vertical interface layer semantic, let's say, pattern that we can extend to other systems, including the oceans. So that was a lot of fun. We have some of the logic here that explains what this thing is to a machine. That it's a front, it's adjacent to two air masses, it's causal agents in some atmospheric processes, etc., etc. So again, this is how the machine sees all of the words that we put in there. And this is really pushed forward the field of environmental semantics, just with a little description starting out over here that pointed us in the right direction with an expert's perspective on it. So that's more or less all I have to say in terms of motivating you to just put in an issue. It may seem it's a small amount of contribution on your side, but it's hugely valuable because it points us in a direction that helps us build something new and improve the semantics that we have in earth science. And of course, we're more than happy to nano-credit you or micro-credit you as appropriate. So please do go ahead, add to the Suite tracker things that you would like to see in there, things that are phenomena of interest, especially if you know where those authoritative vocabularies or standards or descriptions are. And we'll fold it into our work and hopefully create smaller clusters of people to help us extend that. Of course, if you have any motivated students or you yourself are very motivated to contribute, we're happy to train people in actually updating the ontologies themselves and sending in pull requests. These are all community efforts, and we're more than happy to train up new editors. So that's all I have to say. So again, sorry I couldn't be there. It's always fun to be at ESIP, but alas, the ocean's call if I can ever get out of Toronto. So best of luck and enjoy the rest of the meeting.
Thank you, Pierre. Very good. I think that gets us somewhere to the first comment, which is kind of where to get started without being part of the problem. This is where we've ended up after, I suppose, 3 or so meetings now, that we have a reasonably defined, a pretty well defined process for how to contribute. And then when you do contribute, how we can then be actionable and make it in, essentially make those contributions into something that can then be consumed. It's worth stating as well that anything that makes it into both Envo and Suite in that workflow, once merged into the respective ontologies, is almost immediately available. I think within the hour available as linked data. So that can be reduced to the webhook scenario where it's almost immediate. But the point is that this contribution model really enables you to get your contributions into something which you can then go and use. You don't need to wait on a release of whatever, a next 0.0 release or the next major release. This stuff is served through core almost immediately. So getting back with the agenda, before we go into semantic harmonization, I did want to follow on the AGU 29. Yes, Peter. Yes, of course. Any questions, please send them in, please.
Thanks, Peter Fox. Pierre and I had a conversation about this a little while ago, but I don't think you and I have talked, and I'm curious where you are on governance of the ontology changes in respect to monotonicity, which is an incredibly important part of ontology engineering, i.e. what gets broken as a result of the changes that were just made in the ontology. And I'm talking specifically about Sparkle queries more than probably anything else, and where that sort of sits in the process.
Yeah, well, what I will say is that as part of the governance, we do have a review then commit policy, right? So nothing is posted that day and committed that day. Nothing's usually posted that day and committed. It's essentially 3 reviews, 3 reviewers who are typically maintainers, unless it's an update to the README or something like that. If it's a change to a turtle file, then it's typically reviewed by a number of people and made it in. In terms of, I wouldn't, right now, monetization or single source authority over Suite, I don't think it really exists. There's a core community. Kai, can you bring the microphone over here to Beth, or to Chuck then Beth? Yes.
So the other thing that you do is you have releases, right? So
we do have.
So that does constrain some of the, the impact of changes to ontology, because you can sort of specify. So through the Sparkle, I don't know through the Sparkle interface if you have a way of constraining the release version. But that would be the way to do it. One way possibly to do it, right?
Core snapshots each update to any specific IRI. Okay, and you can request a previous version of an IRI. You can also, through core, I believe, request each or a list of versions for a particular IRI. So essentially the metadata about how that resource has changed over time. And then, but what it doesn't give you at that point in time is essentially like a diff between what it was and what it will be or what it currently is. But certainly we do snapshot updates. It's previous information is retained. It's never lost. But it's a very important point and well taken. And we've thought about that quite a bit. I think in particular, we try to address it via the linked data serving implementation core, as well as the developer workflow, the review then commit policy. to try and mitigate against that. Not to say that we're getting it right all the time, but we're trying to mitigate against it anyway. Beth?
Yeah, I think that more or less answered my question too, but I guess my worry is downstream systems that might have been, you know, hitting that ontology for something and doing reasoning sort of separately somehow. If those changes might interfere with those workflows, and is there a way of kind of letting people know, you know?
What I would say just now is that we haven't, I know this, I think it's one of these ones, it's not an issue until the issue comes up, but it is an issue. And I think right now, I don't think it's an issue that we've encountered. That's not to say we won't. Chuck, Kai, can we get the mic over here, please? Sorry, Kai.
Yeah, no, raise your hands.
Thinking out loud. So right now, the versioning, so one way to do this is downstream systems also have to take some responsibility and do the right thing, right? And so if there's versioning information right now in the metadata for the ontology, which there is in the full release, but there's not any in the graph fragments. So I guess that might be one limitation, that if you're using it as linked data and you're pulling a graph fragment, then you have no real way of knowing which version, right? Unless you go to the, how does that,
if you're to pull a slice, or say if you're like, let's just take a very simple case. If you're to pull a class, okay, say you always want to pull something. Maybe it's not a very realistic example, but it's an example nonetheless. You pull a class, the new class level contribution convention that we put in place as a result of the AGU workshop actually tells you what any metadata associated with the class, and it has the revision information, the change log information there. I'll show you an example of that. That's actually it's probably one of the best parts that came out of this 2019 workshop that we had at AGU, was this convention for how to annotate classes and what the metadata for that looks like. And actually, if you're pulling a resource and it has, say, a definition, the definition changes, then there's an additional note that goes in there to say that the definition changed, and here's the person that changed it, here's their ORCID, and a couple of other parts. So we're getting better on that front as well. And actually, we're kind of branching here into more over to what we're going to be covering. I like the way that this is going.
I intend to become a downstream user of this.
Okay, excellent.
So it might be a nice way to work with me.
Very good, Beth. Yep, okay, great. Thank you, Beth. Okay, so the workshop in AGU, bugs and improvements, very quickly here. I'm actually going to start with the right-hand side. This is kind of round the wrong way. I'm going to start here, where we created, or we debated and then agreed upon a new class level annotation convention. I'll go on to show what that looks like. Because that's been dealt with though now, we can deal with the long outstanding issue of providing definitions for all suite classes from both DBpedia and Wikidata. Okay, that's a huge next step for us, because it means that every single resource that you pull will have a definition, a textual definition. It's been a long-standing gripe for a lot of people trying to consume suite, is that we've got an IRI, but we don't have anything over and above that really. We have some relations to other parts of the ontology suite, and we don't have much more than that. Desired alignments, I think it's getting to Richard, your point. NERC has been identified. Stephen, NERC, climate forecast conventions and metadata. These are major tasks. WC3 time and Provo, I believe we need to nudge Simon Cox on those ones really to draw up separate alignment graphs. We have a number of existing alignment graphs. There's documentation on how those can be, on how alignment graphs should be produced. that's on the Suite wiki. The point is here that I think NERC in particular is a very strategic resource for us to try and align with. Pierre is on board with that as well, and I think is trying to evangelize that work. So I think that we'll see that coming up at some point in the future. We did also discuss experimenting with using from, I believe it's over in Envo, but I don't think it's utilised in Envo. It's a predicate has dbxref as a part of the annotations, but we've, I think, put that aside for another convention. The point here is that there was actually quite a lot of work done at the AGU workshop, and I think towards the end of this, particularly the desired alignments, we need to gather enough momentum behind any one of these major ones to move forward with them, because trying to harmonise CF conventions with Suite, for example, with Envo in the mix is a major task. We need to think about how, as a larger community, we try and do that type of thing. The same with the NERC server, vocabulary server. Okay, moving on. Updated class level annotation convention. I've been going on about this. What does it look like? It looks something like this. So this was the output of the AGU workshop. Literally go through it. The reason that we produced this is that folk didn't know really how to, once you provide an annotation, which existing vocabulary do you use to provide that annotation, and how are you nano-credited for it? So that's where we started. We ended up at something like this, where, say I wanted to provide an annotation for representation of data product in particular data set. I essentially would provide the label if there's not one there. It happens to be that there is a label, but I provide a SCOS definition. Yeah, here we go. We provide a comment, the source. In this particular instance, it's from DBpedia. When it was created, when it was modified, and who the creator was. That's your nano creditation, your ORCID. And additionally, we can leverage prov for defining where it was derived from. That there is our current convention for annotating classes, essentially. That's essentially where we're at. That's pretty well agreed upon at this point. If there's any additional contributions that folk would like, or edits that people would like to add at this point in time, then now's the time to voice that, really. But I think that's kind of where we're at with that. And this is major because when we're automating the process of pulling in definitions from Wikidata or from DBpedia for all Suite classes, we need to map those definitions into this structure. That's the point that we're trying to make here. This was a prerequisite for us providing class level definitions across the board for all of Suite. Okay, it's a major outstanding task. Kai, can you please give Ruth the mic, please? Thank you.
So I wasn't at the workshop, but I do have a question.
Yep.
And it'll actually probably come up again when I do my little presentation on glossaries.
Okay.
But so this is coming from DBpedia or Wikidata, but if there are specific glossaries that communities are using, is the recommendation then to go get that community to work with the DBpedia Wikidata groups and make their definitions comply, or what do you do?
Well, you know, one of the things that came up yesterday at the NSF workshop is how much of this is enough in order for us to do what we need to do. I think when we pursue trying to, my personal opinion is that when we try to pursue influencing other communities to do the same as we're doing, the task grows and grows and grows and grows. I think that for the purposes, so once we provided class level annotations for all of the Suite classes, it's a done deal essentially. We can move on and do other things like focus. All of the focus is on semantic harmonization, Ruth. I'm not, I don't, here, how about this one? Provide an example of one of these
Okay.
communities.
The term glacier
Yeah,
is probably, what's in DBpedia is probably not
sufficient.
sufficient.
I agree with that.
Um,
Actually, I think I checked it out and it isn't sufficient.
right. So
You would maybe go to DBpedia. So you don't need, so the other thing as well, at the bottom here, there's a footnote, is that we need to clarify how to support multiple definitions for a class in particular, e.g. one from DBpedia and one from Wikipedia. And I think Chuck in particular has thoughts on how, this has been discussed as well. It's an excellent topic, Ruth.
The semantics of this is relative to the definition for the term as it's interpreted by SWEEP, right? So if we pull in the exact definition from DBpedia, then there should be a one-to-one matching. But that doesn't necessarily mean that we should use that same thing as if it influenced or the other sorts of things, right? So there's semantics that are attached to this what the blank note of that, what that definition actually means, right?
I just wanted to check. I mean, you said having multiple definitions for one of the classes.
Right.
That's
sounds crazy.
They would have to be logically consistent, right? Otherwise, you have two different classes. I mean, this is a concept scheme, isn't it? Not a dictionary.
I agree with what you're saying, but there's another thing at play here as well, which is, say we pull, and I'm just adding another complication here maybe, but say we pull in definitions from DBpedia. Who's to say that and we freeze that definition over at Suite, and the definition changes over at DBpedia? Well, the reason we have all these timestamps and this kind of stuff is that if at some point in time somebody wants to go in the future and edit that, then they can, or modify it, then they can, and that edit is change tracked. Okay, that's another complication. I agree with the fact that the definitions they need to be logically consistent. I agree with that, and that needs to be addressed at the peer review stage. What I think Ruth is maybe getting to is that, and this is what I discovered when I started looking at like the difference between like Wikidata and DBpedia for descriptions, for example, is that some are more verbose than others. I don't think it's that they're logically inconsistent. It's just that we provide more information on the class than the other. Gary, and then Peter up the back.
Well, I entirely agree with the last statement about that some sources capture more information than others. So you have Ruth's work to harmonize things. So we want to go with the harmonized thing. That's the best.
Yeah.
Other sources may be behind the time, and we'd hope they would harmonize over time, or we'd have resources.
Right.
But thinking of this also as a human viewed system, you can say, see also.
Yeah.
The idea of there are other things we don't want to lose historically. These are the way this community discussed it and so forth. So capturing that as part of the record is useful too.
Yeah, I agree with that, Gary. Peter.
So just, Lewis, remind me, so what you've got up on the screen there, the SCOS definition, if this is an annotation, you can have multiple blocks of SCOS definition.
Yeah.
And that's all we're talking about.
Yeah.
No, because, well, let me tell you why. Which wine do you like with your salmon? What type of wine do you like with your salmon? And it's a classic Deborah McGinnis, Jem Hendler argument. Mm-hmm. Deborah, if you all know Deborah, will only have a certain type of white wine. Jem Hendler, just to be difficult, will only have red wine. And both of those are perfectly legitimate annotations on a class or a property. And so this is, I know what you're getting at, Steve, but it's not going to cause a logical conflict because this is not a logical assertion about the class. Right. It's an annotation. I mean, it's an annotation. Let's just sort of stop there. And you could argue that you would preferably only like one annotation, but if you're, depending on how you're using it, it's not going to cause a problem.
Yeah, we're also at the stage here, folks, and I think it's worthwhile us considering this for a second, that when Raskin put all of this stuff together, or Raskin and various others put all this stuff together, it wasn't the same now. It isn't the same now as it was then. So if we think about how, if all this stuff was addressed back then, what would definitions currently look like? And I think we would have multiple definitions for any given class. Yeah, they were. That's correct. Actually, they were GCMD when it started. That's correct.
And the other point is,
which have also changed. Sorry, which have changed since then quite significantly.
Is that because we also have the source, right? That then lets the user have some informed decision about what it is that there may be discrepancies between the things. So you're not. So the other thing we want to sort of prevent is just blind usage of something, right? That I'm an end user. I don't know which one I should use. There's not a lot of information here, so I'm going to pick one. Right. And I may pick one using a random number generator, but that's not necessarily the best practice, right? And so if we can give users more information, they can make more informed decisions, right?
Another thing I would add quickly is that our knowledge representation language may not be up to representing all the things that are in one particular definition. So over time, as our representation languages improve, we may be adding to the ontology, covering things in different definitions that weren't necessarily addressed initially.
Yeah. It's interesting where we've actually come now with this. It started at nano credits for people contributing, and we've ended up, this has been months to get here, really. Anyway, okay, folks, so that's basically an update from where we were in December at AGU, where we're currently at, and I think it's a much better place where we're currently at. Maybe some disagreements, I think some strong disagreements, which is invited, and we should hash that out, and maybe just now, or just now.
I'd just say if they are annotations where you can have different annotations that mean different things on a class, don't call it a definition, please.
What are you saying? It's comment or late?
And I guess my issue with the discussion so far is that in many cases, different definitions imply different entailments. I mean, you might have an additional set of axioms. For example, first year sea ice by definition, salty, green, not blue, certain sickness sizes, certain ages, etc. And so that's where this becomes more complicated, is if you need that expressivity. So Sweet probably will never get there. ENVO is trying to be there.
Okay, so what happens in the case then that we have that we do end up with multiple definitions? And the reason we happen with multiple definitions is because a certain knowledge about a class has improved over time. Then do we just pick, and it's okay for that definition to evolve over time. An example of it would maybe be U values for Windows, right? We've known about Windows for a long time, but U values and regulation round about U values has improved over time, and we've learned more about that. Technology has improved and things have become more insular, and therefore the definition for these things has changed over time. So, and if we had a class for that type of thing in Suite, the definition would have changed over time. So we would have multiple definitions. We would just take the most recent definition.
The way we managed that with the CGI vocabularies that I've worked on, the Geoscience vocabularies for the IUGS, is the idea that it's a concept vocabulary. The definition is the meaning. There's a label, maybe more than one label for it. If you have a different definition that implies a different extension or has different implications, that's a different concept. And you put a new concept in, and you have to gloss the label somehow to distinguish for people when you mean one or the other thing.
Okay, so really, this is kind of getting back to the thing that Ruth is that brought up. Do we want? We've only got so much manpower. Okay, we've only got so many willing individuals to be involved in this. We're not in the business, I don't believe, at this point in time, to scale out annotation of the existing Earth and space systems knowledge resources with all of the annotations we need without leveraging existing definitions elsewhere. Wikidata, DBpedia, okay? If we decide to take one of those definitions, which one do we take? So let me put the question back. Which one do we take? we need to decide.
Well, somebody has to look at them and say, do they mean the same thing?
Right.
And if they don't mean the same thing, then you have to pick one or the other.
Right.
And if you want to have both meanings, you have to add another concept in the vocabulary.
You add another concept.
That's one approach to doing this. Now, I mean, you can also do with what the RDA terminology group is, where they have 6 or 7 different definitions for things, and it's a different kind of tool. It's a dictionary. It means, well, here's a word, and it might mean any of these things.
Yeah.
But that's a different kind of artifact.
Yeah.
If I could just chime in.
Yes, Kai,
the way,
of course.
the way that we are trying to do this in ENVO would be to have kind of a super class that's, like Glacier with a more general definition, and then subclasses that have more specificity in their definition and axioms. So that, as Stefan referred to, you could know which one you're talking about.
What I would hate to see is the class being named DBpedia dataset and the other one being named Wikidata dataset, because I think that's where we're kind of going here, and that to me is slightly ridiculous. I mean, that it's almost as if we're bastardizing the resource, because Wikidata and DBpedia will change independently as well further down the line. Correct, but so then their machines, they can use, I just think that going down that route is relying upon the external party rather than what it is that we're trying to represent, because DBpedia might not even exist tomorrow. Right.
So as the editor of the RDA terminology repository, I want to say that you have to understand multiple definitions. There are only about 3 is the largest we've got, actually. It was meant as a temporary thing so the community could vote on and come to a harmonized definition. It wasn't meant to be that these would always exist as alternate things, but that they were inputs to a decision process.
I mean, that's a different kind of artifact from something that I would call an ontology. I mean, it's basically a tool for building an ontology maybe, but it's not an ontology.
Yeah, I want to emphasize that last point, because especially given an objective of getting machine readability and machine understandability, then when two concepts when the same word has 2 different definitions, those are just 2 different things. And the machines don't care, about what the label is on that. What they care about is, what the concept represented is. And I think we have to keep that in mind, that this isn't being done especially for humans. It's being done especially for improving interoperability. And so, we have to be careful not to get sloppy about, saying, oh, they're sort of the same, and we'll just use the same term.
Absolutely fair point. We'll take one more comment, and I think we need to move on, folks. We've got a lot more to get through.
Yeah, I'm going to disagree a little tiny bit that this is intended for machine consumption, but it's a human conceptualization cast into a form for machine consumption. And so there is a human machine component there. And this is to help the human machine component, to a certain extent, right? So no, but humans have to, we can talk later. Okay.
Right, folks. Omens.
Peter's insinuating that humans write queries.
Yeah. Semantic harmonization. Okay, folks. So, honestly, it took us, when we closed things off, before we go into semantic harmonization, and Ruth, I think you can come forward to say a bit, please. Before we stopped where we did at AGU, it took us the best part of, 2 hours to come up with what we did, or more than that. So it's not surprising that there are additional points of view here, and I think it's great to hear them. To be honest with you, I think we've got a bit more work to do. There's no doubt about it. Okay, so your slides are here.
So I'm reporting on some work that I did actually a couple of years ago now, that was funded by the Global Cryosphere Watch as part of the World Meteorological Organization. And what they did was there have been glossaries of cryospheric terms created for a long time now. And so they were trying to pull all of those together and basically come up with, you know, a set of recommended and desired variables for CryoNet, be consistent in their best practices, and get definitions that they could put in their Medioterm database. And they commissioned me to do two things. One was to look at those 26 glossaries and determine what terms had no problems, what terms had multiple definitions, but they could be coalesced because they're more or less the same, it's just slightly different wording. Noticing where the terminology is inconsistent and might even be problematic from a semantic standpoint. The example I'll give there right now is whether an ice sheet is a glacier or a glacier is an ice sheet, or are they two separate things? There are three communities who have A, B, and C as their primary answers. You know, so one is an A, one is a B, and one is a C. And so depending on who you're talking about, what is different. And then there are cases where you can have a community resolution to either agree or to agree to disagree, in which case you end up with the multiple semantic terms issue. And then secondly, they wanted to report on how those terms align with concepts in things like suite and envo, et cetera, and what to do about that. And so this is what I looked at, believe it or not. I looked at 4,141 definitions of basically 2,200 things in the cryosphere. And about half of them were not problematic. And all the rest of them, well, a fair amount of them, 20%, 10, 20%, something like that, were semantically either inconsistent or needed some sort of community resolution. And I'm going to skip over this one. This is just non-problematic. These slides are, I hope, already on Figshare if you're interested in them. But in many cases, you did have many different definitions and you could coalesce them, and that was fine. And then there are these inconsistently defined terms. And unfortunately, this thing is small enough I can't read it. And for example, in the glossary of meteorology, you know, there's three definitions for what sea ice is. And one of them is any recently formed sea ice, which is kind of weird because it's referencing itself, that is sufficiently thick to impede navigation. Two is in Labrador, one-year ice that forms in bay and inlets. So that's a form of first-year ice, kind of. In the Antarctic, sometimes applied to heavy flows recently broken away from an ice shelf. So those are three totally different definitions. Personally, I don't think any of them are any good. Two of them are dependent on location. And I think there's a super class, which is the real sea ice, that isn't even on the list. And the second example is Bergschrund, which has 1, 2, 3, 4, 5, at least 6 definitions. And the real issue there is Bergschrund is the snow and ice at the top of a glacier that's stuck to the rock wall at the top of the glacier. And depending on what community you're from, that's either part of the glacier or it's not. And so the recommendation I was making is that those get 2 different definitions. And here are some examples of cases where the community needs to figure out what to do. One might be, do we need a cryosphere specific definition, or is, you know, or can the general definition of what a triple point is in general do for everything or not? So these are just some examples of the kinds of things that you end up running into all the time. And then the other report I did was assessed the list of resources you see here. And these were basically the recommendations, which are basically that the cryo community needs to pay attention to the rest of the world and monitor what's going on there and try and insert itself as appropriate. I also recommended that they review GCMD Suite and ENVO, what its current status is. And I made a couple of suggestions, some of which are actually happening, to add the GCOEW glossary definitions to GCMD, the CF conventions, Geoscience, Ontology, Suite and ENVO, which I think we saw that same list on one of his slides. Adding a bunch of instruments and projects to GCMD, possibly suggesting tweaks to the hierarchy of keywords where appropriate, and then basically doing a lot of the work that's currently ongoing in terms of Suite and ENVO properties, relationships, definitions, etc. And then also working with the GeoSciML communities to develop a series of controlled vocabularies for subsets of the terms. For example, a sea ice subset and a glacier subset, etc. So that's harmonization at the glossary level. And you can see that even in a single field of the cryosphere, I think the worst case scenario was 16 different definitions that could not be coalesced.
And Ruth, how long have you been at that? How long have you been working at that?
It took me 6 months.
6 months. I mean,
of pretty much full time.
Non-trivial work, to say the least. Yeah. Okay.
So I'm Gary Bergcross, and Chuck and I are going to present some additional follow-up slides on semantic harmonization. I wanted to, as background, mention that part of this work grew out of on glaciers harmonization. It grew out of a conference at the University of Toronto, where at the end of the meeting, which is on top-level ontologies, we had a dinner to discuss follow-up, and glacier came out as a topic of interest to a lot of people, and we assembled a team and had a form of what's called a vocabulary camp, which was in the form of a hackathon. That is to say, it was a 24-hour, roughly, going from Europe to the West Coast. And we worked on it in waves. And since that time, of course, Ruth and Pierre in particular have followed up on this and moved it forward and developed a lot more than we had at the hackathon. But the hackathon was a start. And other topics now are being proposed for that type of start also. So these slides, if we have time, are organized into 3 parts. First, I'm going to follow up Ruth a little bit, giving you a little bit more idea about the harmonization part. And then Chuck has a more technical view of harmonization from technical level. And then if we have time, I have some slides on foundry ideas. So we'll see if we can get to that. Scroll? All right, okay. Okay, so I wanted to illustrate with a few slides some of the harmonization and refinements that are made from harmonized vocabularies into ontology. So in this case, on the left side, you see some of the existing concepts in ENVO. And the arrow shows some of the refinements that we made, some of the additions we made to ENVO based on Ruth's not only her initial harmonization, but discussions in sessions. And so some of the definitions differed depending on where the ice is, as well as the constituents, fresh versus salt, for example. So those distinctions were not in ENVO to begin with, at least at the level of ice. And so these were added on the other side, as you see. So also concepts like land ice mass were identified. That's with the underlining here. So here's another example of updating some of the ENVO concepts. In this case, it's the ice shelf example, which Ruth mentioned in passing. So on the left side, we see some of the old ENVO axioms for ice shelf. Fine, floating mass, overlaps, and so forth. But on the right, you see the idea of adjacency coming up as an improvement. And you can see some process, how it was formed. And so it just becomes a much richer model based on the conversations and based on, again, the work that Ruth started with in terms of the definitions and looking at what ENVO has. It didn't have a lot of these particular concepts in there, or the definitions of the concepts were not elaborate enough. And I mentioned that there's possible follow-ups in other areas. The ice work might expand into a broader ocean work, but in terms of some of the vocamp interests, I've worked often with the USGS folks on terrain models. And so SWEET has a number of terrain vocabulary items, but they're undefined. And so I've taken a first step of looking at glossaries to put definitions into the spreadsheets we use for cryo. So I've created a separate little tab for these as a start. And in the yellow, you might be able to read this better, are just a tree of the terms that are in SWEET that we have candidate definitions for. Now, what we really need is a domain expert like Ruth in terrain, and there are some from USGS and elsewhere. Rob Sinha, for example, is interested in this topic. So over time, we're going to be developing this, we think. And since these will be published out there, these are the sources I use, since I'm not a domain expert on terrain, but I'm sort of the knowledge engineer that sits in between the domain people and the ontology people. I use this particular source for my definitions. Not all of them were available, the ones that are in SWEET. So I had to go to things like Wikipedia for some of them. So let me turn this hard to read slide over to Chuck, who will explain it all. And if there's time, I will come back on the Foundry idea.
Okay, so this is going to be the sausage making portion of the talk today. So this is going to be some detail about how this harmonization actually occurred through a workflow, right? And so where this actually started was for each of the classes that were in SWEET in terms of the realm cryo, that's where we started, right? We basically went term by term and used Ruth's glossary to figure out what the definitions were. And then, for example, here I have it's hard. I apologize, it's hard to read, but this class is realm cryo flow. Okay. And so the idea is, well, where does that align to? You know, loosely, I use the phrase loosely in ENVO, right? And so one of the things that is interesting that, you know, as part of our workflow is then conversation, right? So the next question is, okay, well, this thing is a subclass of sea ice, and it has an equivalent class to ice flow. Are all ice flows from sea ice? Okay, and the answer was no, that there are freshwater ice flows. And so that then, as far as placement in ENVO, led to another conversation. It's like, okay, well, that means that we need a superclass that is of ice flow type, right? And we have, you know, the definition, as I said, that, or as we said previously, that we had collected from Ruth, and the source for that definition. And then there's some rather more expressive axioms here, right? And so the idea is that we can say things like it's adjacent to a water body, it has some quality that it's buoyant, that it has some quality that's continuous, has some quality that's laminar, it's an water ice, so we can say something about the material constituent, and so on, right? And so then we created the correct alignment point for what SWEET is talking about, which is a sea ice flow. And you can see that here we have some axioms that then distinguish it from just an ice flow in terms of the fact that it's adjacent to some marine water body, not just a water body, right? And so we've now constrained the definition through axiomization, right? And then we create this database cross-reference. And so you'll notice that there's a term sort of right there. I know people online can't hear me, which is a URI that is dereferenceable. So that links back to essentially what the SWEET definition is, right? Now, that then leads to the next question of, okay, that's great. We've got all these definitions and this harmonization in ENVO. How do we get this back to SWEET? And so at AGU, one of the things that at the workshop there that I wanted to start to tackle was the fact that we are enriching ENVO, but we're not really enriching SWEET at the same time, and we need to complete that cycle, right? And so so this is a actual implementation of that template that Lewis was talking about earlier, that gives you a SCOS definition, a comment, a source. Now you'll notice here that right now the DB cross-reference, okay, is right now just an RDF comment because we haven't come to an agreement about how to actually do that. And so that then goes back to the next part of our workflow as a community, right? So I said, this is great. We've come to an agreement on the annotation of the definition, but how do we create this sort of link between the two definitions, right? And so I created this nice, GitHub issue in SWEET and said, okay, where do we go from here? We've got a couple of options. Chris McGill, Mungle, excuse me, commented saying, I think that we should use SCOS definitions, right? And gave a link to his nice sort of a blog post on the whole thing, right? And so here, if you go through the blog post, there's sort of three different options that I sort of wanted to go to. I'm going to go to option 2, right? So this is, all this is it has no meaning. It's just a link, right? And this is a historic sort of accident of how the bio community developed databases and created identifiers and sort of has some historic context. But there's no context about what the relationship between the definitions actually are. It's just a URI that points to another database that has a term. The second or the third option that he gives in his blog post, which is the one that he recommended that we adopt as a community, and this is open for discussion, right, is that we can use SCOS vocabulary. So we can now use these mapping relations such as close match, broad match, narrow match, exact match, which has a lot more semantics that are attached to it. But those come with some baggage, right? And he's going to go, if you go to this issue in GitHub, you can get the link to this. Actually, I have the link at the bottom here of the slides also. And you can go into the downside of that, right? That there are some issues between OWL and SCOS that are historic from the W3C, how they were implemented perspective. And then the most sort of rigorous thing that we can do is a direct logical equivalence. So we could create an equivalent class relationship that basically said that the ENVO term and the SCOS term, or excuse me, the ENVO term and the SWEET term are an equivalent class relation. Now that's fraught with all kinds of issues, right? Because that means that logical entailments that are applied to the ENVO class get applied to the SWEET class, right? And so that's sort of the most strong relationship, and sort of the architecture of SWEET right now, that is done through the alignments directory, right? So if we want to make a very strong statement about something, we put that in an optional graph that's not brought in as part of the default graph, and that gives you some modularity in controlling the implications of those sorts of entailments. Given that we have sort of some limited time here left, I am going to let, I think, Gary go to his brief statement about maybe where we go from here, and then I think we probably have some time for
stay there because you have some foundry things too. So this is just the OVO as a point of comparison. What's been done to create a foundry? These are some of the concepts and relationships that the OVO foundry has had. So what might it be for us? I mean, obviously in the bio realm, we have molecules, we have cellular components, we have metabolic processes and mechanisms, so forth, functions. What might it be for us? Well, I think and you have the next slide.
Yeah, so I tend to get talks stuck in my head, so I'm going to credit Christoph for this particular view of what the next sort of thing. I'm going to skip this slide, although I think it's useful. And so what I suspect, so if you look at the OVO foundry, right, class of sort of ontologies, right, the thing that they have that ties them together sort of is BFO, right, which is an upper ontology. But upper ontologies have a lot of problems with them in terms of you know, trying to capture the entire world and entailments that may or may not be correct, right? And so I think that part of the discussion about, you know, this is, you know, the next year, 5-year, 10-year sort of roadmap of where the harmonization could lead to is that I suspect that patterns may end up getting lifted from both ENVO and Suite and make itself into the sort of this global pattern level that's here, right? And this will create a hopefully a little bit more interoperability at the logic level, which we're sort of missing. Right now, we're looking at more the annotation level, right? But we also want to create interoperability at the logic level. And so hopefully as we're doing this process, right, we're identifying some useful candidates. I think as we go through more and more, we'll identify candidates that could become what is the Earth Science Foundry or whatever it is, Earth Data Foundry, that I think that Pierre and Louis would like to get to. So with that, I think we have 7 minutes or so left. I will turn this back over to Louis, or actually back to Gary.
2 parts, sorry for the switching. So I had a slightly different take on part of the foundry. So while they created this for another presentation, I think it's relevant here. So this is one early take on some of the fundamental areas that we would be dealing with in the Earth and space science realm. The top is somewhat abstract, physical objects and notions like shape and features, space relationships. And coming down from that, and this is all, by the way, this is based on a number of people's work, but in particular, Mike Gruninger at Toronto and his student Thorsten Hammond, for example, Boyan Broderick, who was listed as going to be here, but isn't here, has done some of this work. I've adapted it for some of the things that we have done in the past. But in any event, I've illustrated it with the idea of, again, sea ice, water, and that type of thing, as you see coming down from the geo bodies. You distinguish the features from the bodies and the constituents and so forth. And some of these features are contained in things like terrain, which are defined, partially contained, and so forth. So this presents at least a portion, I think, of some of the things that we would have in a foundry. And my last slide, which is actually applicable to lots of our discussions, is that we have lots of different repositories of knowledge. Remember, I had that semantic gradient idea. We have, you know, thesaurus, we have these controlled vocabularies and so forth. It is very challenging harmonizing all of these things, which often are stored in very different ways. And so this diagram sort of gets a little bit at that. As we do a foundry, we have to sort of keep track of, we have to keep in mind this idea of making sure we understand the relationships between all these things. I have a few little technical things floating around here, like SCOS. So some of these, there are some technical things that link these things in some way. We have repositories. Zazuko is something that Chuck is using as an ontology development environment, which gets a little bit documentation of what it is, so you can find things and understand things and so forth. And he has also mentioned ontology design patterns, which are these very small modules of things that adhere, like the semantic trajectory or this the SSO type of pattern, which can be particularized and generalized. And so these things that might be starting points like seeds for growing out the foundry. And with that, let me turn it back to Lewis, and I'll just leave this slide up for some of my thoughts on moving forward, but you may have others, and I'm sure we all would welcome comments.
I think that's a nice area for us to reflect. Some of what we've seen today, I think, is quite practical in nature about how to make contributions, what kind of work is going on, and we're finishing up here really with where we want to take this in the future. One of the glaring white elephants in the room here is that few domain experts are being funded for lengthy enough times to make significant contributions here. That's really one of the barriers. This is one of the situations where we have more ontology engineers or computer scientists who lend their hand to this type of stuff than we do domain experts. And we really need that sanity check from the domain experts to get this kind of stuff right. I think it's important that we get it right because there's a huge, the slide that in particular Pierre showed, where he had Chebby chemical compounds and earth science and environment and this type of stuff. That there is really where we want to get to. And I think that we, as a community, certainly have a great potential to be part of that larger, pattern fabric. I think that that we should continue this semantic harmonization track is certainly worthwhile. A lot more investment. So really, where I think we should go, my opinion is that we have a semantic technologies teleconference on the 3rd Tuesday of the month, I believe. Wednesday of the month. It's up there. Thank you very much. So we've got one coming up towards the end of the month, and we had anticipated maybe having Marshall Ma come and talk about some of his work, but it might be pertinent for us to maybe delay Marshall's work or presentation and discuss this concept of a foundry. Most of the harmonization work has been done between the individual telecon and the cluster which is dedicated to that topic now. So there's no absence of opportunities and forums to get involved in this kind of work. It's all been somewhat, I suppose, orchestrated through Semantic Technologies Committee. So anyway, where do we go next and what type of stuff do we focus on was kind of the last part. We've got a few minutes here. In terms of this topic of alignment, Gary had mentioned, so we've been working, or work has been going on in Cryosphere. Gary had mentioned potentially land use, land forms and terrain. It's been identified that NERC, vocabulary server, is certainly an area where there is interest to pursue, but again, we need significant investment in time and expertise to achieve that. The NERC vocabulary server is a huge knowledge resource, and harmonizing between Suite Envo and NERC is a significant challenge. The same goes for climate forecast conventions. It's a huge, huge knowledge resource, and it's going to be a significant undertaking to address that there. But I think these two. Then we've got over in the W3C, we've got W3C geologic time, which is gathering a lot of momentum or time, and Provo again over at W3C. I think Simon Cox is probably the person to spearhead that work, to be honest with you, with contributions from round about. But I suppose the question back to the audience here, to the community, is if you're interested in any of these harmonization activities, to, I suppose, maybe either mention it now or get in touch on the mailing list, let us know about it, and then we can start to plan out what the logistics of that would or what it would look like, and what the tasks would entail. The other part of it is how we what an architecture for the Foundry looks like moving forward, and whether or not it's a good idea or not. I think Chuck, Gary, and myself have probably slightly different opinions of what that would look like at this point in time. Pierre is probably, again, slightly different. I think we're all on the same team, we're all on the same page, but we're just at different parts of the page, I think, just now. And I think that we need a lot more input from around about the community to build consensus on where we go with that kind of thing. I should also say as well, before we kind of wrap up here, how much time were we meant to have left? Are we meant to be finishing? We're okay. We're -1 minute. Okay, we're working on a suite publication, folks. If you're interested in contributing to that, a number of people have been using suite, consuming suite. It's 15 years on since the initial 2005 publication, so or it'll be 16 years actually. So the intention is to get another publication for suite out, and it's a community publication. We're looking for contributions on usage, your understanding of what the knowledge resource is, and all this type of stuff. If you're interested in getting some information on that, get in touch with myself. Finally, very last thing, there's a suite ontology channel on Slack, the ESIP Slack workspace. So if you're interested in keeping up to speed on a lot of this stuff, then catch us on there. Hope you enjoyed today. If you get any feedback, please send it to me, negative, positive, otherwise. It's a series and we're trying to improve these as we move on. It's quite challenging, I think you'll agree, but hopefully you got something valuable from it today. And thank you very much, everybody.